Hi everyone, thank you for tuning in to my presentation on Leucine Zipper. What is Leucine Zipper? Leucine Zipper, otherwise known as Leucine scissors, is an example of a coiled coil and is a common three-dimensional supersecondary structure in proteins. Coiled coils are formed when two or more alpha helices self-assemble by winding around each other to form a left-handed supercoil. These alpha helices are rod-like in its structure with a tightly coiled backbone. As most helices found in the proteins are right-handed to reduce steric clashes, the two right-handed coils intertwine together to form the said left-handed supercoil. The most common coiled coil structures are dimers, trimers, and tetramers. Leucine zipper gets its name because the zipper consists of two alpha helices with leucine occurring every 7 amino acids on a length of 8 helical turns in the dimerization domain. A dimerization is an addition reaction in which two molecules of the same compound react with each other to give the adduct. The localization of the leucine is critical for the DNA binding to the proteins. Leucine zippers are present in both eukaryotic and prokaryotic regulatory proteins, but are mainly features of eukaryotic cells. But how are these two alpha helices held together? The two alpha helices are held together by hydrophobic interactions between leucine residues, which are located on one side of each helix. The hydrophobic side chains extend out from each helix into the space in between the two helices. Hydrophobic interaction between the leucine molecules is packed in tightly together, increasing the stability of the domain, as can be seen here. In addition to the stabilizing hydrophobic core, the leucine zipper is also held together by electrostatic interaction between the positively charged side chain of lysine and negatively charged side chain of glutamic acid. Replacement residue and destabilized core. The similar mass, hydrophobic nature, and the long carbon chain length of isoleucine and valine would make them comparable residues for leucine. Due to the likeness of their nature, replacing leucine with either isoleucine or valine would ensure the stability of its domain is maintained and avoid the risk of steric clash. Conversely, as the core is made up of hydrophobic residue, any hydrophilic residue can destabilize the core by breaking up the hydrophobic interaction present. Due to the hydrophilic residue's water-loving nature, the hydrophilic amino acid would much prefer to be exposed to the aqueous medium on the exterior versus being tightly packed together in the core. Thus, residues such as serine, aspartate, and histidine would destabilize the core, as they would much rather prefer to form hydrogen bonds with the aqueous exterior environment. But are there any other amino acid pairing whose side chains would interact in a similar manner? The answer is yes. The side chains of any pair consisting of one acidic and one basic amino acids at their neutral pH level would interact like lysine and glutamate by creating an electrostatic reaction. An example of a possible alternate pairing would be arginine and aspartate, as seen here. Well, that's it. And thank you so much for watching, and I look forward to seeing everybody else's presentation. Bye.